Hey everyone, and welcome back. Haven't done a tech video in a while. I think most of you know why. I've been crazy busy on another project, and if you're not exactly sure what I'm referring to, go back and look at the past few videos we've put up. But anyway, so I haven't done a tech video in a while, and there seems to be a lot of debate and discussion on engine break-in. And there are very different methods for engine break-in. Now, of course, I did a video a while back on proper break-in procedures, but I didn't really get too much into the real technical side of why engine break-in is so important. And there's a lot of, I would say, misinformation out there when we're talking about those break-ins. All right. First off, let's talk about camshafts, right? Now, if you're installing, of course, all of our Harley engines, modern ones, they all have roller lifters in them, right? Roller tappets. You really don't have to do a break-in on a roller tappet, and I'll explain why. That came from when you're installing new flat tappets on a cam. And basically what you want to do with flat tappets is run the engine 1500 to 2000 RPM, somewhere around 15 to 20 minutes, all right? And the reason that that is done is to promote rotation of the tappet on the camshaft, okay? It kind of sets it in and it gets things, just kind of gets things working and moving and all that type of stuff. So part of that at that RPM promotes the tappet spinning inside its bore so you get even wear on the tappet. That's the reason you run the RPM on flat tappets. Well, roller tappets don't spin around. So there's really not a need for it. So obviously there's considerations like other, little wear items, things just seating in and all that. But the primary reason for an engine break-in procedure has to come with the ring seal. Now, when you bore and hone, I'm going to sitting station several times. And when you bore and hone, you're leaving a crosshatch behind. That crosshatch doesn't look, you may be wondering why I'm holding a file. That crosshatch really doesn't look too dissimilar to the teeth like you see on a file here. All right, so the idea is that those little scratches that are left, their job, that crosshatch, is to retain oil to lubricate the piston. All right, but when you hone a cylinder, very much like you sharpen a knife, if you're sharpening a knife just on one side and you look closely, you'll see that knife edge actually curls over like this. And then you have to sharpen the other side to remove that curl. So when you're honing a cylinder, if you look at it microscopically, those crosshatches, they can fold over like that, right? Creating, kind of a weird ridge. During the break-in procedure, you have the edge of the rings, you have combustion pressure that's forcing those rings out, and very much like a file, the crosshatch is actually grinding slightly into those rings, and that's where your seating comes from. Now, there's also a second step that we take and many others take during the honing process, and it's called plateau honing. All right. The reason that that's important is if you just left those little tiny curls in there as the engine is breaking in, those curls can break off. We're talking microscopically, but there's a lot of little edges in there. So that can actually promote premature wear, and it just makes for a dirty break-in period during that very sensitive part of it, right? So with plateau honing, what you do is instead of it being sharp points, you're actually honing just enough to flatten those points out, and it makes more of a shape like this. Okay? Well, the purpose of plateau honing as a last step is to rapidly shorten the amount of time it takes for that ring to seal. So the reason you vary that RPM up and down is so that you're creating combustion pressure to force that ring out, to really grind it into that crosshatch and then create that perfect seal there. And to plateau hone, you can do it a couple different ways. You can, typically it's done with about a 600 grit, give or take, not enough to really remove any material, but it can be done with a brush, 600 grit brush, and a certain number of strokes. And then you can also have inserts, which I have mine as well, that are plateau brushes that you put in the head of your hone and run it up and down a few strokes just to clean those edges up. But that is the purpose of really truly breaking in an engine, is, and you have a very limited amount of time to do that. Understand, it's at some point, those edges in that cylinder are not going to be quite as sharp. So you have a very short window of opportunity to take advantage of the abrasiveness of the crosshatch and also that coating, that surface on the side of the piston there, okay? And then the idea is to take advantage of that rough surface and mate them together quickly. Now with improper break-in procedures, like maybe you're just taking it real easy, you're not varying the RPMs, you're just steady state type stuff, you're not creating enough combustion pressure to force those rings out and grind them in. And what can happen when you do that is not too dissimilar to windshield wipers. So, and I'm sure you've experienced it. You know, your windshield wipers working fairly well, and then at some point they'll skip. Reek. Well, reek, like that, right? Reek. That's a good technical term, right? Once a windshield wiper starts doing that, you can never stop it. It'll do it forever. Unless, you know, you've got to put new wiper blades on and then spotlessly clean your windshield and all that type of stuff. The exact same thing can happen with piston rings. And quite often, it is an improper break-in procedure, taking it too easy, that will allow that ring to start skipping in that cylinder, and that's why sometimes you'll see freshly built engines smoking and consuming oil, is because of that skip, very much like windshield wiper blades. Pretty interesting, huh? This is also a reason why getting, in that other video I'd mentioned, getting your air-fuel ratio as close to perfect as you can, as quickly as you can get it there. I disagree with the theory of a break-in map. Typically on a break-in map, they'll run it a little bit richer, because a little bit richer is safer than a lot lean. The unfortunate part of that is if you run one too rich, you're actually diluting that oil mixture and inside the cylinder itself, right? You get that blast of fuel in there, and that can actually also prematurely wear the ring and the piston. It's got to have time in order for it to seat. Well, if you remove some of the lubricity, then it's not wearing in fast enough and grinding that ring. So what can actually happen is you end up with prematurely all those little edges that you need for the break-in on the side of the cylinder, the crosshatch, those can be worn away quickly before the piston ring itself has had time to actually grind into that sidewall. So that's one of the reasons why it's so important to try to get that air-fuel ratio as close as you can possibly get it, as quickly as you can get it. And I mean like within the first 20, 30 miles. I don't agree with the break-in map. Set it where it needs to be and run it. And then after you get, you know, a bunch of miles on it, it's not a bad idea to go back and confirm it, but I would not intentionally run an overly rich break-in map. Another reason for break-in, on our pistons, we do utilize specialty coatings on our piston skirts. And those specialty coatings require a very specific break-in procedure. One, they are that coating is clearancing, but it's also, tempering's not the right word, it's curing. So that's why we're doing multiple heat cycles, just enough to begin the curing, give that coating enough time to clearance, but then also cure it with each step a little harder and a little harder. But what you don't want to do is 15, 20 heat cycles, because with 15 to 20 heat cycles, remember, every time you're hitting that switch with that cold start, you're blasting a ton of fuel into that cylinder. Again, running it overly rich and potentially restricting the engine's ability to grind those rings into that cylinder at the right time. There's an enormous amount of technology that goes on with this kind of stuff. And in other words, to give you an order of priority, for example, I'm hesitant to give very specific break-in procedures, because the break-in procedures are really, in all honesty, largely determined by your piston manufacturer, your piston ring manufacturer, and the person that is honing your cylinders. What method they use, what grit they use. Not all piston rings use the same crosshatch pattern. They also don't always use the same coarseness of stones. It's, you know, it's RA, RMS finishes and all this stuff, surface finishes, when you start looking at frequency depth and all this type of stuff, very much like sound waves. different piston rings, different shapes, different sizes require different finishes. Sometimes those different shapes and sizes require different break-in procedures. So I would caution you, if you're building your own engine, don't just arbitrarily ask anyone, how do you break it in? Because it depends on the parts you're using and the method by which your engine was prepared. So I would say my best advice would be to talk to the piston manufacturer, the ring manufacturer, and those instructions will typically come with your pistons and rings. Talk to the person that bored and honed your cylinders, find out if they plateau honed or not, which that'll reduce the life of it. And the biggest piece of advice I could probably give you, 2 pieces. Do not use assembly lube in your cylinders. Use oil. There is a debate on break-in oil, which has a high zinc content. This is something we are going to cover when we do the Klotz tour. Okay, we're going to talk about break-in oils, and we're going to talk about, zinc and a lot of the stuff that's floating out there and a lot of myths and things. But, break-in oil is a consideration. Then whether or not to run, natural oil or to run synthetic oil during the break-in procedure. And so many of these questions are answered by the piston and ring manufacturer. So just as with many things in the machine shop, there aren't always de facto answers for questions. And the responsible thing for me to tell you is investigate, I can tell you on our components what to do, but your components may be different, right? So I would be doing you an injustice by telling you do exactly this. But as a general rule, you do not want to do just steady state cruising. This is pretty much the same for all piston and ring manufacturers. Just steady state cruising for 500 to 1,000 miles you will not get as good of a ring seal, and it's an issue that you will really never get back. Once that crosshatch is ground down, once that ring is ground down, you'll never get that opportunity back. So, 1, get your air fuel mixture as close as you can get it, as quickly as you can get it. Okay? Number 2, don't do an excessive amount of heat cycles. You're not helping anything by doing that, you're hurting it. Do the number of heat cycles required to meet whatever coatings or whatever, varying parts that are in there. Do the number of heat cycles they recommend and follow that progressive nature of those heat cycles. Okay, that's number 2. Number 3, do not use assembly lubricant. It's too slick. Your rings will never break in. You want to use the oil. I use the oil that I intend on running in the engine to do all my break-ins, but yours may be different. Again, talk to your ring manufacturer. So you want to vary those RPMs. You want to roll into it nice and hard. You want to get up to, 4,000 RPM. Get it up there and then decelerate. Build that negative pressure. Build that positive pressure on top. And that really grinds those rings into the cylinders. And if your air-fuel ratio is proper and your cylinders have been plateau honed and all the procedures are done, virtually your engine is broken in after, as far as rings and cylinders are broken in after about 30 to 40 miles. If they're plateau honed, depending on the finish and several other things, remember there's no de facto answer. But again, as a general rule, do not steady state run. Roll into that sucker, get it up to $4,000, even $5,000 every now and then. Bring it back down and do that, do that repeatedly. When I say repeatedly, normal riding, I ain't talking about going out and thrashing it off over and over again. I'm talking about normal ride, back roads, through the mountains, roll into it, roll back off, do that sort of thing. And then the other is keep a very close eye on engine temperature. Pay attention to that. You do not want to overheat one during that break-in procedure. It's very important. All right, guys, I hope that helps you understand the importance of engine break-in and what's really going on inside that engine. And the reason for changing your oil, I actually, 500 miles is okay. I like, change it at 500, change it at 1,000 or whatever. I like to change it a lot during that first, maybe change it 2 or 3 times during that first, 1,000, 2,000 miles, because you've got break-in contaminants, right? All those little edges in the crosshatch. You've got machining things. When you're doing as much machine work as gets done on these engines, sometimes it can be near impossible to get every little tiny microscopic bit and piece out of it. So you're clearing all of that stuff out of there. So the oil changes would be, frequent oil changes during that break-in is is a great thing to do. So anyway, guys, there you go. There's your tech tip. I hope to be able to put up some kind of tech video in the next couple of weeks. Of course, I'm going to be putting up videos of finishing up the new place, the build out. We've got all kind of stuff to do. And then of course the move, setting up the equipment and all that other type of stuff. So pretty excited. So I know it's a wide array of videos, and this is a motorcycle channel, but we've talked about wire and electrical, we've talked about framing, we talked about building stairs and all this other kind of stuff. But you know, it's all cool, and we're building stuff. Guys, thanks a million. Thanks a million for your continued support, your kind words, all your comments. There will be a time in the near future I can actually answer all of them and be able to help you guys a lot more. Thank you to all of our members for sticking with us every month. You guys are rock stars. I appreciate you very much. Take care of yourselves and each other. Have a good one.